So we'll have to, of course, the solution of linear differential equation with constant and variable coefficient, linear differential equation with constant coefficient. That means these ki's are all k's are i's constant. That is the above equation. This is the linear differential equation can be written in the form this. The general solution of this equation is CF plus PI. So this is quite important. Now the CF is obtained from by taking this thing is equals to 0, right? So this, if we take this thing equals to 0, so from here m to the power n plus k1 m to the power n minus 1 plus dot 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 kn is equals to 0. So from here we can obtain, and from here we can obtain a complementary function. And from here we can obtain a particular integral. So from here we can obtain a particular integral, right? So that's the important thing. Now so case 1, if all roots of the the differential equation auxiliary equation B m to the power n plus k1 m to the power n minus 1 plus dot 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 plus kn is equals to 0, then it's called auxiliary equation, and the let m1 m2 mn be its roots depending. Now case 1, so here we'll obtain case 1. That means it will clearly have n roots because the degree is n, so it will have n roots. Now what is important to notice that out of these m roots, so this will give clearly m roots, they will give m roots, right? So there is no doubt on that. Now suppose if all roots are real, so case 1 says that, say all roots are real and distinct, say this is the first case. So in that case what will happen? M1 M2 dot dot dot. So what we can write is that we can write the auxiliary equation as m minus m1 and m minus equals to 0. So this is the important thing, right? So in that case, so m is equals to m1, so m is equals to m2, and m is equals to mn. Now y is equal to c1 e to the power m1x plus c2 of e to the power m2x plus dot 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 cn e to the power mnx. So this is the required auxiliary complementary function. That is so this is simple. Case 2, suppose that two of the roots are equal. Say m1 equals to m2 and others are distinct. Say now So this is the case 3. Now case 3 is that may be the case okay, we can further extend if m roots are equal, k roots are equal, then cf is equals to cf. This is cf, right? Cf c1 plus c2x plus c3x square plus dot ck. So k constant must be there because and x to the power k minus 1 of e to the power mx plus ck plus 1 x to the e to the power m2 of x plus dot like this, right? So that's what is important for us, right? So that's what, right? So say m1 is equals to m2 is equals to dot mk is equals to m. So that is important. So case 3. Now case 3, if a pair of roots are imaginary, pair of roots are imaginary, right? So let us suppose that imaginary, suppose that m1 is equal to alpha plus I beta and m2 is equal to alpha minus I beta. So then the complete solution is y is equal to c1 e to the power alpha plus I beta of x plus c2 e to the power alpha minus I beta of x plus c3 to the power m3x plus dot cn to the power mn of x, right? So that's now what is important to look at. This can be written as e to the power ax into c1 cos of beta x plus c2 sine of beta x plus of c3 to the power m3x plus plus cn e to the power mnx, right? So that is important. So that is important. So that's it. If the two pairs of say case 4 it says that two pair of imaginary roots. So what is important to note that if you have two pairs of imaginary roots, then why cf is c say m1 is equals to alpha plus minus I beta and say a plus minus ib, right? So this is two pair of imaginary roots. So e to the power alpha x c1 cos beta of x plus c2 sine of beta x, so plus say e to the power ax into c3 cos bx plus c4 sin bit x. So case 5 says that if m1 equals to m2 equals to alpha plus I beta and m3 is equals to n4 is equals to alpha minus I beta, then and cfp is equals to e to the power alpha x c1 plus c2 of x cos of beta x plus c3 plus c4 of x sine of beta x. So that is important. To note that, right? So this is the cf. So some result about second order, it always bound some consider some. Okay, so that is the all about the differential equation of second degree. That means solution of linear differential equation on constant and variable coefficient, right? So that is all about the things. Now we'll study some important problems. So we will have a second order homogeneous differential linear differential equation with constant coefficient. Consider the differential equation, say of the form y double dash plus a of y dash plus b of y is equals to 0, where a comma b belongs to R, right? So that's what. Then this differential equation, it is important to know that this differential equation always bounded and periodic solution, right? So it is important to know that this is the one type of special differential equation. Say y dash plus 2y dash plus 3 equals to 3y equals to 0 has bounded and periodic solution, which is yx is equals to has a, that means always has a, y bounded and periodic solution. Yx is 0 is bounded and it is also a periodic solution. So what is important to note that it may have more than one solution, but what is the important, that it has at least one solution, which is which means that at least one solution which is bounded and periodic. This means that if you see such type of equation, then y of 0 is always a solution and y equal to 0 is always a solution and it is bounded and periodic. So question 2 says that if roots are auxiliary equation real and non-zero, then non-trivial solution is never bounded and periodic on R. So what is important to know, that if y equals to 0, then the solution is bounded and periodic. So the question is arise whether we have some other condition in which the solution of this equation, this differential equation, is bounded and periodic. So what we can say, that if roots of the auxiliary equation, if the roots of the auxiliary equations are real and non-zero, then non-trivial solution is never bounded and periodic on R. That means what we say, roots of the auxiliary equation are real and non-zero. If the roots of the equation are real and non-zero, then the trivial solution is never bounded and periodic on R. That means what we can say, auxiliary equation, the roots of the auxiliary equation, say m1 and m2, and m1 and m2 are real. So periodic on R. If roots are real and non-zero, then non-trivial solution is never bounded and never. This is important to note, the never bounded and periodic on R. And third one says that every non-trivial is bounded and periodic. So that's important. If roots are imaginary, so that is important. That is when the roots of this equation will be imaginary, when if b square minus if a is equals to 0, and it is of the form m square plus am plus b is equals to 0. So what is the discriminant? The discriminant will be b square minus 4ac, that means 4b, right? So it will be less than 0 if a is equals to a, it is less than 0, b square minus 4 is c must be less than 0 for this. That means a square less than 4b. That means so this condition is satisfied. So if we say that is right. So so in that condition, a square is less than 4b, a square less than 4b. So in that condition, this root will be the root will be imaginary and purely imaginary, right? Imaginary, purely imaginary, not only imaginary, purely imaginary. So that is not true, right? So that is not true. Purely imaginary, that is. So one concept is that what is purely imaginary? Purely imaginary, that means so we have to know what is purely imaginary. Say number is 2, the number 2 is the real as well as complex number, imaginary number. But this is not purely imaginary, because in purely imaginary, a number a plus ib is said to be purely imaginary if a is equals to 0. That means and b is greater than 0. So b should be greater than 0. So in purely imaginary number b, that means the imaginary part is non-zero and the real part is 0. So that's what is purely imaginary. So this is very important problem, right? So this is what we have to know about this. And next we will came across some important problems. So that's all.